Lesson 15, video number 4. We're looking at solving, verifying, and graphing with the inverse trig functions. Okay. The first one we're looking at is 13a. Now, in this problem, you'll notice that we have sine inverse of 3/5 plus cosine inverse of x equals pi. Big important detail here is that every time we're working with the inverse trig functions, we've got one of two situations. First situation is that I have a number or a fraction inside here. Okay. Now, if it's a fraction of sorts, we're going to have to go back to the triangle. And that's what we've done in the last couple of videos, is go back to the triangle. But if it's an angle measure that we know, okay, that spits back, so for instance, radical 2 over 2, I know that value. I know that the sine inverse of radical 2 over 2, because I know the sine of what angle measure is equal to radical 2 over 2, okay? So it's either going to go back to the unit circle or it's going to go back to the triangle. Keep that in mind. It's one or the other, okay? So what I'm going to do here, as I did in all my other problems, is I'm going to look at these inverse trig functions. This question is to solve. My x is here. I need to get that all by itself, okay? The only way I'm going to be able to do that is if I can first manipulate this. Well, every inverse trig function is equal to an angle measure. I'm going to call that alpha. Okay? If I call that alpha, that means that I'm going to have sine inverse of 3/5 equals to alpha. Okay? With that, that means I'm going to take the sine of both sides and get 3/5 is equal to the sine of alpha. Well, that's kind of nice for us, because then I can go ahead and create myself a triangle. Sine being here, alpha, I'm going to have 3 to 5, and once again, this is 3, 4, 5 triangle. It's always those nice ones, okay? Now, with that being done, what does this stuff happen to be? Well, then I have alpha plus the cosine inverse of x is equal to pi, which means that the cosine inverse of x is equal to pi minus alpha. Well, how do I eliminate the inverse trig function? Well, I take the cosine of both sides. Again, to get rid of the inverse function, I'm going to take the cosine of this side and the cosine of this side. These cosines are going to cancel and be left with x equals cosine of pi minus alpha. Okay? Now, this is great for us. Unfortunately, it's not a single angle. I don't know what x is equal to at this point. So what I'm going to have to do is I'm going to have to actually go back to my identity formula sheet and say, well, what's in here? What is something that compares to this thing right here that I can utilize? And you'll notice this identity right here, cosine of x minus y, is one we can use. So, looking at my identity and following that x is pi and y is alpha, this is really going to be equal to the cosine of pi, cosine of alpha, plus sine of pi, and sine of alpha. Okay, what's the cosine of pi? I believe that's just a -1, remembering the unit circle. Again, back in the unit circle, here's pi, it's going to be a value of -1 comma 0. So that means that this value over here is 0. So I have -1 times the cosine of alpha plus 0 times the sine of alpha. That cancels it all itself out, and I'm left with negative cosine of alpha, which, if I look up here, I already found the information for alpha. For cosine, it's 4 over 5. So this is equal to a -4 over 5. And remember what we were solving for? X. I have solved for my x. Okay, so problem 13a is done. Let's talk about 14a next. Okay. So problem 14a gives us this. Sine inverse of x plus the cosine inverse of x is equal to pi over 2. Okay. Now, what we're trying to say here is verify this. Guarantee that this is true at all times. So for any angle x value that I can plug in, sorry, not angle, any number x value that I can plug in, I will 100% of the time get pi over 2. Okay. Now, if that's the case, what I need to do with these is, well, you know, what we did before. Every single time, let the inverse trig function be an angle. So I'm going to let that be alpha, I'll let that be beta. Now, why am I going to let these two things be separate? Well, because they're two different things. They do work in the same triangle in theory, okay? But I don't know what they really are. Okay, again, I know that these two are angles, I just don't know what they are. I don't know what the angle values actually are. So, if I let this happen, again, let alpha equal the sine inverse of x, then in this case, what is x supposed to be equal to? I'm not sure. But right now, I'm not really worried about it. Okay? Let's actually go ahead and look at this. This is the sine of alpha is equal to x, technically over 1. So if I create myself a triangle for this, I have alpha here, x over 1, and this thing right here ends up becoming 1 minus x squared. Again, Pythagorean theorem. Okay, so then up here, let me look at the beta equaling the cosine inverse of x. Well, if that's the case, that means I have cosine of beta is equal to x over 1. Well, if that's the case, I'm going to be looking at a triangle here, and I'm going to go ahead and do the exact same information. I have beta, okay, and cosine is x over 1. What's this side? Well, the same thing, 1 minus x squared, okay? So, what information do I really have here? Well, I have sine of alpha, I have cosine of beta, and I'm kind of lost with this information up here. But then again, maybe there's something else I can do, okay? And this is where it's kind of, I'm just going to pull this out of nowhere, okay? I'm going to try something. I'm going to see if I can make something work. This right here is going to be alpha plus beta, okay? Now, I want to prove that this thing is always going to be pi over 2. Okay, I want to prove that this thing is 100% of the time equal to this. Now, this is not something I'd expect you to do. It's something I expect you to see, understand, and possibly in the future reapply. Okay? What I'm going to do is I'm going to say, well, I do know that I can take the cosine of this, alpha plus beta. I also know that if I do that, what do I have to do? I also have to take the cosine inverse of the whole thing as well. This will allow me to, change sine inverse x plus cosine inverse x into an angle. Then it will allow me to utilize the information that the inverse of actual function, okay, cosine inverse of cosine, they cancel each other out. So I didn't really change this thing. I just changed how it looked, okay? It's like taking the square root and the square root of both sides. It's like multiplying by 2 over 2. It's like adding 2 and subtracting 2 to the same side of an equation, okay? So that's what I'm doing. Well, what is the cosine of alpha plus beta? I have an identity for that, okay? And again, it might not have made sense for me to do this immediately, but now that I can look at an identity, maybe it might help to notice that this thing here, okay, can be manipulated. So I'm going to go ahead and do that based on this identity right here. Okay, so this is going to be the cosine inverse. This is equal to the cosine inverse of cosine of alpha plus beta, which is really the cosine of alpha, cosine of beta, minus the sine of alpha and sine of beta. Okay, so I'm going to move this around here. Again, this is cosine of alpha, cosine of beta, minus sine alpha, sine of beta. Okay? So, when I do that, I actually know what the sine of alpha is, and I know what the cosine of beta is, and I have, if you look over here, my triangles. And if I wanted to, I can actually identify what the cosine of alpha is in this triangle. Cosine of alpha would actually be equal to, well, the square root of 1 minus x squared over 1. Okay. Likewise, I would need the sine of beta, and the sine of beta is actually equal to the square root of 1 minus x squared over 1. Okay, again, sine of beta is opposite over hypotenuse. So, with all that being done, I'm going to plug everything into here. Cosine of alpha is the radical 1 minus x squared. Cosine of beta is x. Minus the sine of alpha is that radical 1 minus x squared. Okay, and the sine of beta is, sine of beta is that sine of alpha is x. Wait a second. This is cosine inverse of radical thing x minus radical thing x. Those radical things are the same. The inside crap is just 0. This is the cosine inverse of 0. I'm going to ask this question. What angle measure do I have to plug into the cosine function in order to get 0? And again, where is that defined? Okay? I mean, the inverse trig function is defined between the values of 0 and pi. So what angle measure will provide me between 0 and pi in the unit circle, okay, of a cosine value of 0? And that's pi over 2. It won't work down here, okay? This is pi over 2. So by some fancy manipulation, this thing right here, alpha plus beta, which is really cosine inverse cosine of alpha plus beta, is really pi over 2. Okay, that completes problem 14a. We are now going to look at the graph problem, and the graph problem I will do right here. Okay, it is very, very simple. Okay, the problem itself asks you to graph. Okay, it asks you to graph the function y equals cosine inverse of x plus 1. Now, notice in my actual thing, I've written the parentheses, and they are not actually on your paper. That is okay. If they're not on your paper, that plus sign tells me that the rest of the stuff after is not actually inside the inverse function. Now, there's a lot of stuff we could do with this. What I'm going to do with this is I don't remember the inverse trig functions. It's hard for me to do that. So I'm going to go back to the original trig functions. I'm going to look at this thing here. Okay. This goes on forever in this direction as well. This is cosine of x. Okay. What does the inverse function look like? This thing reflected around. So this point 0, comma 1 is going to be now placed at 1, comma 0 over here. Okay, and I know that if I were to look at this thing coming down this way, it's got to come down this way. Okay, now it's got to come towards the y-axis instead of the x. So I see this thing here goes to here, and then I have to stop there. Why do I have to stop there? Because if I don't, it doesn't pass the vertical line test. Okay, this works for the cosine inverse of the function of the variable x. Okay, for sine it's a little bit different. We actually have to go from negative pi over 2 to pi over 2. Again, we did that in the previous videos. Now what do I do with this plus 1? You shift it up 1 unit. Okay, that's it. So this was at a value of 0 to pi. Now it's going to be at a value of 1 here. Okay, and we're going to go ahead and graph this function up to here. Okay, and at that point we're going to have pi plus 1. Okay, and that right there is the graph that I'm looking for. Okay. That finishes lesson 15. Make sure you jot down any questions you might have, bring them to class, and ask me then.